contains duplicate. Given an integer array nums, return true if any value appears at least twice in the array, and return false if every element is distinct. In this case, 1 appears twice, so we return 2, and here every element is distinct, so we return false. So our brute force option is to pick an I element and then compare it with every single element in the array. If it matches, then we return that the duplicate is present and we return true. And if while traversing every element, if we don't find it while we reach the end, so we move the I to the next element and then check again. And if we don't find it, we'll return false, and that will be of O of n square time complexity, and we will be using O of 1 space. So we have an index I that traverses on the nums array, and then an index j that traverses from the I plus 1 to nums dot size. And if nums of I and nums of j are equal, then we return true, else we return false. Okay, so another way you can solve this is to sort this array, and when you sort this array, you will get this kind of array 1, 1, 2, 3, and we can traverse this array. And if we have two elements adjacent to each other that are same, then we can say that duplicates are present, and then we can return true. And while traversing, if no duplicate is found adjacent in the adjacent element, then we can return false. So this method will be taking O of n log n time complexity, n log n for sorting the array, and O of 1 space, as we are not using any extra space here. Okay, so here what we do is we sort the nums array and then traverse it from the starting to nums dot size minus 1, because we need to check for the next element. So I will go to nums dot size minus 1. So, and if the ith element is equal to the next element of the I, then we return 2, as when we sort two adjacent duplicates, if present, will be side by side. And if no adjacent elements are the same, then we return false at the end. So a better way will be to use a hash map. Hash map will store every element as the key. Here, like we go 1 and we have the count as 1. So, and then when we go for 2, the count of 2 will be 1. When we reach 3, the count will be 1, and we see 1. So here we'll increment the count of 1 to 2. So then we traverse the hash map. If for any element we find the value to be greater than 1, then we return 2. A better way will be to use an unordered map and traverse in the array with the key and its frequencies. So you traverse in the array and then add the frequencies to the map, and then while traversing the map, if the frequency of the key is greater than 1, then duplicate is present, then return true, else we return false. So, a more optimal way will be to use a data structure known as a set that will store the unique elements inside it. While traversing this nums array, we will store every element that is unique. So, it will contain 1, 2, and 3. As 1 appears again, it's a duplicate element, it won't be here. So, if you have the set size and nums.size as the same value, that means there is no duplicates present, and set size remains same, so we return false, else we return true. Optimal way is to use an unordered set here. We are using an unordered set rather than set because an unordered set uses hash tables rather than red black trees in a set that gives it fast lookup times. So we just add every single element into the set, and if the set size is equal to nums dot size, then we return false because then no duplicate is present. Else we return true if the set size is smaller then the nums dot size, it won't be bigger, it can be smaller. So return 2 in this case.